This is problem 7-6. Here you're given allowable. Your maximum allowable in shear is going to equal to 7 times 10 to the 6 newtons per meter squared. So now all we're going to do is use this equation here, that the shear stress is equal to the shear, which is V, times Q over the moment inertia times I times the thickness that's occurring right there. Okay, we know when we have a cross section like this that the maximum shear is always going to occur at the midsection. So all we're going to do is draw a line here, and what we're looking for, our Q value is going to be, and I'll kind of sketch this in, we're trying to find out all of this area here, 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 and here, and then multiply it by the y bar. Now remember, Q is not a difficult equation. It's just going to be the area times the y bar, and the y bar being the distance from here up to the center of the section. So we'll do Q first. Okay, what I would do in this one is break this into three parts. You got number 1 here. We'll call this number 2 because it's identical as the other one. And this is number 3. Now if you don't know where your center is, you'll have to calculate where the centroid is. This one's symmetrical, so this one's not bad at all. So we'll do number 1 first. The thickness is going to be 0.05, convert that back to meters, times the height. This thing is 200, so that would be times 0.1 meter. And now the center is going to be the distance from here to here, which will be 0.05. Okay. Now we have 2 of those, this one and this one the same, so might as well just multiply it by 2 instead of doing it twice. Now we'll do this one here. Its area is going to be 0.10 times its thickness, which is be 0.05. And then the distance from here to here. So the easiest way is we're going to go up 100 and then we're going to come back another 25. So that gives me 0.075. That's my Q value. And I'll grab the calculator real quick. We'll run that number there. That's 0.05 times 0.1 times 0.05 times 2 plus 0.1 times 0.05 times 0.075. That gave me 8.75 times 10 to the 4th. And that's meters to the 4th. Actually, meters cubed. I'm sorry, meters cubed. Because that's area times distance as meters cubed. Okay, so now we can run this problem. Before we do that, though, we should probably get the moment inertia. If I were you and I was going to find out the moment inertia, now the moment inertia is we want the full moment inertia of this whole entire piece, not just half of it. So to do that, we're going to take 1/12, and what I would recommend is make this all one big rectangle. I guess this case will be a square, and then subtract out the middle. Let me get rid of this real quick. Alright, so the base of that is going to be 100, that'd be 200, that'd be 0.2. The height of this is also going to be 0.2. We'll subtract out the middle of this. Now we're coming back down. That's going to be 100 by 100. So it would be minus 1/12 times 0.10 times 0.10 cubed. I'll run that value real quick. 1 divided by 12 times 0.2 to the 4th, be easier. Minus 1 divided by 12 times 0.1 to the 4th power. And that gave me a value of 1.25 times 10 to the minus 4th, and that is meters to the 4th. Alright, so now we just put our values in and we'll solve. We use the equation right here. 7 times 10 to the 6 is equal to V. Let's scroll up a little bit so I got a little bit more room. Is equal to V times Q, which we said was 8.75 times 10 to the minus 4th over a moment inertia, which is 1.25 times 10 to the minus 4th. Now, here's what you gotta be careful with: the thickness. The thickness is going to be the distance from here to here, and then from here to here, because that's the material thickness. So we got 50 here, 50 here, that's 100, so it would be 0.10 would equal to the thickness. And now you're just going to move everything to the other side and solve for V, and when you do, you'll get 100 kilonewtons. And that's all there is to it. Nothing very difficult. Probably the most difficult thing is just learning how to calculate Q here, and then make sure that the thickness is the thickness of the material, not just empty airspace. It has to be material. All right.